Hi, hello dear. So welcome back to a new video. In today's video, we are going to see the last topic of this unit, distribution law. Okay, so this distribution law will called as Nernst distribution law. Okay, so when we are adding a substance to a immiscible liquids, how it is going to distribute? Okay, that we can learn from the distribution law. So for example, we had taken the beaker, okay, and the immiscible liquids like oil and water, which is not miscible, right? So we had taken the oil and water. So we have the water and oil, and additionally we are adding a solute. So this solute, how it is going to distribute in the both phases, that we can study from the distribution law. Understood? Yeah. So this Nernst distribution law, we can tell like when a solute is distributed between two immiscible solvents at constant temperature, the ratio of its concentration in the two solvents will remains constant. Okay. Once the solute which reached equilibrium in the solvents, the ratio will be same. So, provided the solute exists in the same molecular state in both solvents. So, we can represent the Nernst distribution law K or KD. So, we can calculate the partition coefficient by C1 by C2. Okay, distribution law, we can tell partition, how your solute is getting partition into the both phases. Okay, so partition coefficient or distribution coefficient Kd is equal to C1 by C2. So where here the C1 is the concentration of the solvent A, maybe it is organic solvent, by concentration of the aqueous phase, concentration of the solvent 2. Okay, so this is how you can calculate the partition coefficient. So when this solute will chooses the two liquids. So we have taken the two liquids, right? That is immiscible. So your solute which you are adding, it will decide where should it go more. Okay. So that is depends upon the solubility of the particular solute. The solute is soluble in the solvent A or solvent B. It depends upon that it will go and distribute. So once the equilibrium is reached, the ratio becomes fixed. Okay. So more soluble solvent which will give the higher concentration. Next, we will see what are the conditions for distribution law. So your solvents which we are using, the solvents must be immiscible. It should not be miscible. Okay. Then solute must be in the same molecular state. Once we are adding, your solute should not change into the other molecular state. Then temperature should be constant throughout the period. Then no chemical reaction with solvents. That means we are taking the two immiscible solvents, right? So that two immiscible solvents should not react. It should not take any chemical reactions. These are the conditions of your distribution law. Now comes to the application of the distribution law. Extraction of drugs. We can extract the drugs like drugs from the aqueous part to organic part, like that. Okay, it's like drug purification, natural product isolation. Okay, next comes to the determination of partition coefficient. In that we can learn the drug absorption, how your drug is going to get absorbed. That's based on the partition coefficient. Okay, then drug distribution in the body, how your drug is going to get distributed in the body. Next comes to the drug absorption and bioavailability. If higher the lipid solubility, will get the better absorption. Then determination of association or dissociation. If your solute associate in one solvent or dissociate in another, that we can learn. These are the application of your distribution law. Now comes the last one is the chromatography. That means partition chromatography, separation we can do by this. Okay. Now, yeah, comes for the last topic, that is limitations. Limitation means first one, solute association. If your solute molecule is getting associated, okay, in any of the layers, your law will get failed. For example, benzoic acid in benzene and water. Benzoic acid will get associate in the benzene layer. Okay, so in that case, distribution law fails. So that's what we are using, the modified distribution law. Next comes to the solute dissociation. That is, this solute dissociation is applicable for the weak acids and weak bases. So, if solute ionizes in one solvent, ratio it won't be constant. Okay, so weak acids in water. Next, chemical reaction with the solvent. You should not get reacted your solvents. Then, change in temperature, because we know temperature should kept constant. Then, solvent miscibility. If we are using the miscible solvent, law is not applicable. This law is only applicable for the immiscible liquids. So I hope you understood. This will come for the 5 marks category as well as 2 mark category. Okay. So we have to give what is distribution law, and you have to give the formula how you can calculate the distribution law. Okay. Then you have to write the conditions and applications along with the limitations, which will give you the 5 marks. So I hope you people understood. In next video we will see a recap of unit 1. So bye bye.